Uh, yes, now it's our turn to our dear speakers, Mr. Robert Gold. He's going to present to us a lovely 1 hour of time giving the speech about the innovations and inventions and his experience during more than 40 years. He has many inventions, becomes like 100 products in the market. It's a good time for our audience to spend a lovely time with Mr. Robert. Mr. Robert, it's your time now.
Thank you very much. How do I share my screen with you? Let me see here. This is what I need.
Yeah, yes.
There we go.
Good.
Okay. Can you see this screen here?
Yes, lovely yellow and white maze, yeah.
Okay. First, I wanted to introduce myself just a little bit. I've been an innovation consultant for going on almost 40 years now. I've worked for everybody from small companies to the Fortune 500, the US military, and various government agencies. I've developed several renewable energy products, among other patented inventions. And this presentation today is going to look at innovations and concepts, progress in the renewable energy field. Some of it you'll be familiar with, others you might not. I'm hoping it's all interesting to you. First, I wanted to say that innovation is the combination of three things: what is possible, what is desirable, and what is marketable. And it's only in this small section in here that real innovation takes place, that actually makes it to the marketplace. Innovation methods for creating energy is where the majority of effort is currently focused in the multiple fields that we'll be speaking about today. These are the 7 areas of conventional renewable energy production. The only one that might also be here, but we're not talking about today, is nuclear. These include hydroelectric, wave, tidal, solar, biomass, geothermal, and wind energy. We're going to start with solar energy. The sun is at the center of it all. Every day, the sun pours more solar radiation in the form of photons onto Earth than we need for an entire year to power everything on Earth. Could be powered in one day if we had the ability to collect all of that energy. You might all know his face, Elon Musk. He once said that if we wanted to power the entire United States, all we'd have to do is take a small section like this, 100 square miles, with solar cells, and we could power the entire United States. Well, right now, I don't think that's possible, and I'm not sure he was correct. There are too many good renewable power sources that can do the job better than taking 100 square miles of the country, any country, whether it's here in the States and, excuse me, Europe, the Middle East, anywhere. There are so many different ways that we can do this. Right now, silicon is really the beating heart of solar products, and it's been that for the longest time. But there may be a revolution coming. That revolution is called, and I keep saying this wrong, perovskites. Perovskites are thinner, lighter, 33% more energy efficient, and they cost 15 times less per watt than normal solar cells. And they could be the future of photovoltaic. And we're going to run a short video here to introduce you to them. Whoops.
It's a new kind of thin film technology, so you've probably heard of that for a long time. Different kinds of thin films have come and gone over the years. What we do here is a new kind of material. It's called perovskites. New semiconductor material that absorbs light really effectively, also transports charge. So it just turns out to be very efficient material for solar cells.
Solar cell technologies can be classified into two categories: wafer-based or thin film cells. Wafer-based cells are fabricated on semiconducting wafers and are usually protected by a material like glass. These are the crystalline silicon cells you'll typically find on bulky roof-mounted solar panels. Thin film cells are made by depositing thin layers of semiconducting films onto a glass, plastic, or metal substrate and use 10 to 1,000 times less material than crystalline silicon cells. These thin film cells are light and flexible but have lower average efficiencies. You can make thin film cells from amorphous silicon or more complex materials like cadmium telluride, but scientists have been on the hunt for better thin film solar technologies that can see more widespread use. These materials are known as emerging thin films. Currently, perovskites are the leading contender. What could you do with a solar panel with 100 times the power-to-weight performance of conventional silicon panels? A solar material so abundant, it could be painted on skyscrapers. Flexible, lightweight, highly efficient cells could open up a wide range of applications where traditional silicon cells are too heavy and rigid. But before we cover your Tesla Model S Plaid in perovskite solar, what exactly is this revolutionary crystal? The perovskite crystal structure was first discovered as the naturally occurring mineral calcium titanium oxide, but the perovskites used in solar cells don't need to be mined from the earth. A perovskite is any material with a crystal structure following the formula ABX3, where A and B are two positively charged ions, often of different sizes, and X is a negatively charged ion. Scientists realized that they could create a diverse range of man-made perovskite crystals following the same arrangement that have very useful properties.
So we use basic, metal halide salts. So things like lead iodide or some organic salts as well, and we combine them to make these inorganic, organic hybrid perovskites. So if you can form them in solution, you can form them in vacuum, out of vapor phase, and they condense into forming these perovskite crystals. And the thin films, they're like
are perovskite solar cells. The most efficient modern silicon solar panels you'd find on a home only work best at around 20% efficiency. But the theoretical conversion efficiency of single-junction solar technologies is about 33%, called the Shockley-Quasar limit.
That's the fundamental limit for a single solar cell, single material-based solar cell. Perovskites are the exact same thing. Silicon, perovskites, cadmium telluride, CIGS, all of these technologies have the same limit.
But perovskite solar cells can be made in a form factor that's capable of much higher efficiency limits, pushing the boundaries of possibility for solar power.
That's one major breakthrough that is really escalating in the marketplace right now. Another is the fact that they've come up with ways to make printable or paintable solar cells, which will mean people can just paint their homes, paint buildings, whatever, paint vehicles even, to collect sunshine and energize their vehicles or houses. They're also using carbon nanotubes to create some of these paintable technologies, and these are 50,000 times smaller than a human hair. So this is really advancing the technology very rapidly. Another recent breakthrough from the University of Cambridge, and also spoken about in the Journal of Solar Materials, are materials that are grabbing 100% of the energy carried by photons. And this is ridiculously powerful, since most solar cells, as was just discussed, only absorb about 20% of the energy, and the perovskites will do 33%. So when they get these hybrid cells actually going out of this organic material, they're going to be able to harvest much larger amounts. If they make it to 50 or 60%, it will be a revolutionary breakthrough, and it will change solar forever. Next, we're going to talk about geothermal energy. A quick review: what is geothermal energy?
ever observed an erupting volcano or the geysers at Yellowstone National Park, you've seen geothermal energy in action. The Earth's crust is made of rocks and water. Deep below that is a layer of hot, molten rock called magma, which is even hotter than the sun's surface. The heat just over 6 miles below the surface contains 50,000 times more energy than all the oil and natural gas resources in the world. Releasing a small amount of that heat in the right way can create electricity. A well drilled a couple of miles deep can capture the rising hot water and steam. That steam spins a turbine, and a generator produces electricity. Geothermal is one of the least explored sources of renewable energy in the US, and most of us probably don't spend much time thinking about it. But since it's a pollution-free, renewable source of energy that's consistently reliable, at least it has been for the past 4.5 billion years, maybe we should.
So if it's such a great thing, why is geothermal energy such a limited resource? Well, there's a very simple answer. All geothermal energy up until now has been located at naturally occurring thermal vents. Hot springs, geysers, things like that. But these were all located in places that aren't the most hospitable or easiest for industry to use. But to get geothermal energy, people had to locate their businesses so that they could take advantage of this naturally occurring thermal source. Well, that's changing. A company called Fervo, and let me see, is an advanced drilling company. They were into all sorts of drilling technologies for years, but they've now developed the next generation geothermal projects that can deliver 24/7 carbon-free energy. And how they're doing this is something called the enhanced geothermal system. Using their advanced drilling technologies, they're capable of drilling holes way down into the earth, putting down piping where they're flowing water down there and injecting water from the surface, and then bringing it up as very high pressure steam, turning that into electric power. Now, this is something that can be done anywhere. It's no longer exclusive to thermal vents or geysers or anything like that. We can do this in deserts. We can do this in tropical areas. We can do this in the middle of any country, in the middle of a farm. You could drill these holes and bring up thermal energy. And I feel after researching this, that this is going to really change the renewable energy landscape. Geothermal is going to become a large part of that energy component. The next we're going to talk about is wave energy. Now, wave energy is important because 70% of the planet is water. And 3 of our electric components here, hydroelectric, wave energy, and where are we, tidal, are all water-based energy sources. So let's take a quick look. What is wave power? Wave power is created by wind, and it creates the renewable resource that keeps waves moving all over the planet. Now, what you're looking at here is a float on the surface moving up and down with the waves. Now, what is that doing? It's pulling a cable that has magnets on it, and those magnets are constantly moving inside of generator coils, which, as we all know, is creating an electric current. That electric current is going into the foundation down below where it's anchored to the seabed, and then cables take it into the land where the energy is then used or stored. And you can have literally thousands of these energy pumps sitting on the waves. There are 2 types of major wave action renewable energy that are new, and I think they're revolutionary. One is the wave, what we call bobbing up and down that we just saw. But the other one is something called a wave reservoir turbine. And it's very, very simple. You basically create a structure that floats in the ocean, but half of it is above the water and half is below. And as waves crash into this and go over the top, it fills a reservoir up here, which feeds a turbine that drops the water back into the ocean. And these can be anchored, and they can just float around. And the higher the waves, the more water goes in here on a regular basis. And basically, it's very simple and elegant. And it's just one of the many new wave capture designs. The two that we've just spoken about, the bobbing up and down generator, which is a different configuration shown here, and the reservoir, the wave reservoir turbine, are two of the latest technologies that are being introduced into the wave section of renewable energy. Our next one is wind energy, which I think most people are familiar with. Today, this is a common sight. Huge bladed wind energy generators seen across landscapes all over the world. But few people realize, just between this period, I don't have the latest up-to-date numbers, they're not really out yet, but from 2003 to 2013, there was a exponential jump from 2,000 patents, or actually 1,000 patents a year being filed, to over 8,000 patents a year being filed in the worldwide wind turbine power generation systems of those systems. So innovation is just exploding in this field. We're going to talk about 4 of them first. 3 of them, these 3, they're straightforward but very innovative ways of creating power with wind turbines. The 4th one, I have my doubts about. And I've included it here because basically I want to make the point that not all of those 8,000 patents a year are credible. There are a lot of schemes out there because of the interest in wind power generation that every inventor, and sometimes not really inventors, but people just trying to make a dollar, are putting things forward that don't always work. But let's talk about what's out there. New World Wind has come out with what I feel is a very unique concept. It's eco-friendly, and they mimic trees and bushes. And each of these devices on here is both a small wind turbine and a small platform with solar cells. So it's catching both wind and solar, and they can be put in parks, they can be put on rooftops, they can be put almost anywhere without looking like you have a tremendous amount of machinery cluttering up the landscape, which is a major concern for some people. They want their eco-friendly wind technology, and most wind technology doesn't look eco-friendly. Although most of it is, it just doesn't look that way. And this is a unique new concept that allows you to place a lot of wind turbines, small, but it's cumulative, in a location, and have it look more like trees and bushes than a lot of machinery. The next one, Sea Twirl, which we're going to show a little video here. This is a great technology. It's important. Let me get some information here. Oops. Sea Twirl is important because it's built to withstand storms, hurricanes, and it can be placed places where other types of wind generation turbines cannot be placed, and that is in deep water. All other wind turbines have to be placed in fairly shallow water because they're actually mounted into the seabed, whereas Sea Twirl actually floats, and it's held down to the seabed only by cables that keep it from moving. But the actual system is carried by the buoyancy of the water, and it allows it to be in much deeper water. And why this is important is because the deep water is where you find the strongest winds. It's not really by the shore, it's out in the open ocean away from shore. So this is an important new type of wind turbine that is stabilized by its heavy weight, but its ability to sit out in the open ocean really changes the complexion of the wind turbine. We have a couple of little blurry parts here, I'm sorry, but I think I've already told you what that's trying to say. Offshore, where the winds are the strongest, that's where you can place these. We'll be done with this in a moment. The Sea Twirl turbines, like I said, can be put way offshore and in much deeper waters, and that makes them a real contender in this industry. VLAT, which stands for vertical axis wind turbine, is a new type of vertical axis wind turbine. Although we've seen a lot like the Twirl, this wind turbine is segmented so that it can have different spin rates, and that makes the spin velocity less damaging to the foundation where it's placed. So you can create the same or more energy with one of these than you can with a comparable one that is just one solid wind turbine. Here you have a comparison between a HAWT, which is a horizontal wind turbine, horizontal axis, and a VAWT, the vertical wind axis, and they have different uses in different places. The Watt is better close to shore. The VWAT is better out in the open ocean. And the Twirl is of this type of turbine, and but designed like this, it is simple and it is not sensitive to wind directions, so you don't have to worry that you're aiming it in the right way like you do with this type of turbine. So this is a new type that we've seen before in smaller scales, but allowing it to be anchored out in the ocean is really turning this into something that is cutting edge. Now, this is, I laugh because I've looked into this, I spent hours looking at this technology because I didn't want to badmouth something unless I really had my concerns, and I do. This technology supposedly works by the wind pressure against this surface that produces tiny piston movements that converts to hydraulic pressure, which then converts to electricity via a hydraulic motor. I have severe doubts about this, especially since they've already raised a lot of money and this technology still doesn't have an experimental production model. They haven't shown that it really works, but they're touting the zero blade wind turbine and raising a bunch of money on it. And I say you don't raise money on something unless you're got proof positive that the energy source functions. Whereas we have this, which is a project by the University of Japan. This is huge. These are about 100 feet high, And these wind turbines, when they actually can get models built, I think are going to be very productive. And I'm not sure if they're going to be an eyesore or they're going to be a tourist attraction. I like the way they look personally. Now we've come to the most interesting, what I consider the most interesting part of the wind-powered products. What you see here are a flying or gliding wind power product and a floating wind power product. Let's talk about the flying one first. It acts as a glider and it uses the winds at above 2,000 feet to keep it up and keep it flying. But it has some downsides, although the upside that if it can be raised, this turbine can be raised into the 30,000 foot level, you're going to get 20 to 40,000 watts per meter of power out of it, which is just truly enormous. But you're also talking about having a 30,000 foot cable hooking one of these, and it's going to produce at minimum 2-mile no-fly zone around them, so that aircraft aren't like smashing into these or to the cables. But it is an interesting concept. More interesting is the BAT, the Buoyant Airborne Turbine. This has been tested since 2014. They're now going into a production run, and this floating turbine, you can see the turbine in the center here, can go up to 1,000 feet in the air and generate enough for, I think, this size. They did a number, I think, it says it here someplace, 5 times powerful. I know it did a number of homes, did like 20 homes or something with one unit. They're forecasting that they could put an entire battery of these floating in the sky and power entire cities with them. But an important part of this is not just the power generation. It's the fact that Wi-Fi and cell towers could be built into these. So even small towns could fly these above them, generate their electricity, and provide Wi-Fi and cell service for that location. Next, hydroelectric, back to the water. And again, a small primer on what is hydroelectric.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are 2 main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
Right now, pumped hydro is one of the largest systems used globally as a hydropower resource. And it's getting even more popular. And here are the two types. An open loop pump storage uses a reservoir that is part of a dam, and it pulls water in and out of there to create power when needed. A closed loop pump storage uses an upper reservoir and a lower reservoir, and using electricity purchased at a low rate, pumps it up to the upper reservoir, and when they need power and the rates are high, they let it flow through and it goes to the lower reservoir. It is estimated that only a few hundred pumped hydro sites would be needed to support the entire renewable U.S. electricity system. It seems like everybody has their own view. Elon Musk says it's 100 square miles of solar cells. The people who quoted these statistics say it's only 100 or so pumped hydro sites, but I believe it's a combination of all the different types of renewable energy that will see the world through to a new era. But you can see that United States does not use that much pumped hydro compared to China and the balance of the world. A lot of these countries use pumped hydro in much smaller amounts though. But one of the things that's happening now are people are realizing that not just gold mine, that should be mine, M-I-N-E, excuse me, an abandoned gold mine. Yeah, that made me laugh. An abandoned gold mine in Australia, two of the pits are now being used as a pump hydro facility. So people are finding ways to create pumped hydro renewable resources where there are no natural water supplies. And our third and final water renewable energy is tidal energy. And there's a lot of innovation in this space. And again, a quick primer on what is tidal power.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity, and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
There are two new types of innovation in tidal energy. The windmill type and the tidal kites type. And here you're looking at one of the large new windmill systems that is put offshore to use the tides. One of the types that we just heard about, the tidal barrage, is also unique in the fact that it really doesn't use the tidal power itself. It usually uses the force of the tides to create air pressure, and we'll see that in a moment. Here's a typical tidal barrage that uses a tidal basin and the ocean to make the water flow back and forth, and these can be placed where the topography creates the configurations that make it easy enough to install. The tidal kite I just mentioned is a new type of tidal system that is actually a kite that is moored to the surface of the ocean, but it flies back and forth in a figure-8 pattern, absorbing the electricity via a turbine that is in the body of the kite. It's sort of like a little airplane, but a kite on a string, sending it back and forth, and it can just stay there forever, picking up the power. And right now they have a 1/4 scale unit in North Ireland, and they hope to put more into the ocean out there very shortly, full scale. Here's what I was talking about. The power of tidal motion is used to pull air. As the tide goes out, the water lowers and it sucks air in through the turbine and spins the generator. As the tide comes in, it presses up in and it makes the air pressure move through the turbine the other way, spinning the generator again. So you get both motions, tide in, tide out, generating power without the actual water doing any work other than exerting pressure inside of this chamber. And because of how this works, this is much easier to place up and down many coastal areas around the world than the other systems. But tidal power is still advancing in many ways, like this standalone twin-bladed turbine that can be placed in many areas inside and outside of tidal basins, anywhere where the tides are powerful enough. Let's talk about biomass. And again, I'm going to show you a quick primer.
Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity. Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas. The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions. But it can be a smart way to make use of waste. Power to the poop.
Biomass combines nature and technology to effectively solve many types of waste problems and increase clean energy resources. As you see, well, I'm using all information from the United States, but as you see, biomass actually produces 9% of the power in the United States, almost as much as wind power, more than nuclear, more than solar. And it's almost as much as fossil fuels. The only thing that's much higher than that as a renewable energy is hydroelectricity. And there are so many ways that we can use biomass to improve the environment. And there are almost too many to list at this point. But there are biomass facilities, small ones, but effective, that are popping up all over the country to remove bio wastes that are produced by farms, by animals, and forests. And this helps eliminate many types of waste from town dumps, at the same time producing electricity and taking away many environmental hazards. And there are plans in the works for very large-scale biomass facilities to be built all around the world. And a facility of this type and size could take in thousands of tons a month of waste that could be turned into electricity and pumped back into the power grid. All in all, renewable energy technologies combine to form a future that is less wasteful, more energy efficient, and more easily sustainable. Thank you for your attention. If you have questions or comments about this presentation, you can contact me or the presenter, and copies of this presentation are available if required by email request. And thank you very much for your attention.
Thank you, Mr. Robert, for what you showed us of many things of innovations in each technology sectors of renewable energy. I think people here, they are already enjoyed what you delivered, especially, you know, the multi areas that you cover in this presentations. Thank you, Mr. Robert. Now we have two parts of our event today, and now we still have like 10 minutes. We have still like 10 minutes of questions for Mr. Robert. We hope now the guys who already would like to participate as comments or questions, they use the raise your hands icon, so they can deliver the questions to Mr. Robert. Now we'll go to Mr. Ali Imran, but before that, I think Dr. Megaidi is here. Who's there? Let's try the Samir Al-Qurashi.
Yes, I can hear.
Yes, we can hear you, Mr. Samir.
السلام عليكم ورحمة الله وبركاته. مهندس سالم يعطيك ألف عافية إن شاء الله. Thank you, Engineer Robert, for the presentation. You went over all the energy renewable all over the world. In fact, I have a very good question, which is regarding the geothermal energy. You mentioned that to inject the water in order to absorb the heat to generate the electricity out of it. Now, what type of water that it can be seawater, or it has to be clear water?
As far as I know, it has to be clear water. I know that some people are experimenting with seawater, but it has a downside. Seawater takes a lot more energy to heat, but that is really not a major concern since the heat is not being produced from a fuel that we have to store or create. We're using the ground energy. So the other concern is that seawater is highly corrosive, and that the type of materials that would have to be used if we're not using some sort of clean, purified water as the element that is pumped down, we're going to have to worry about the integrity of the pipes, or else they're going to be much more expensive from what I understand. But it's a trade-off. To be able to use seawater is a major positive thing, but the use of a better quality of containment system, the pipes that you'd use and the pumps that you'd use have to all be basically functional with a corrosive seawater passing through them. So it depends on how much money the companies that are going to use this, especially that Fervo, how much money they want to invest or what their technology is already set to use. That's the best answer I can give you at this point.
Thank you, Mr. Robert, and thank you, Mr. Samir, for your questions. Now we'll move to Mr. Abdul Majid.
Hello.
Yeah, hi, Abdul Majid.
I have a question regarding the grass. Can you get the grass be used as a biomass feed source? Because we are generating a huge amount of grass.
Yes, the grass can be used. I saw your question. It just has to be dried out so that it can be burned. If it's wet, it'll take time, but anything can be dried out over time. It can be put in dryers. That's an additional cost or energy concern. But if it can be dried out, or it is already dried out in your application, yes, it definitely can be used for biomass.
Thank you, Mr. Robert, and thank you, Mr. Abdul Majid, for your questions. Now we'll move to Ms. Hana Abdul Malik. If you are still here. We'll go.
You have your mute on.
Yeah, she should turn it off or turn it on the mic. Let's go to Mr. Fuad. Mr. Fuad. Okay.
Just take your mute off.
Yeah, maybe if they are using the phone mobile, maybe it's not easy to remove it. I don't know. Let's move to Mr. Saif Ramadan.
Hello.
Hey, Mr. Robert. I have a question regarding geothermal energy. Is it convenient enough to use or to build a complete station with that cost in a specific location, and which will actually not stay forever?
You want to build a geothermal station as a temporary station. Am I correct in what you're saying?
It is actually temporary. Geothermal does not stay forever at the same location.
Well, it depends on how you're doing it. The new geothermal technology is drilling wells deep enough that they will be able to use those for years, maybe forever. But if you're using it at a thermal vent, that also has a long-term application. I just want to throw out, because you made me think of this with your question, I've always had the idea to put a geothermal setup, and it could be temporary and could be moved at some of the major coal fires that have been burning for 70 years in different places around the world. There's one, I think, in Virginia or Tennessee in the United States that started, I think, more than 100 years ago, and has never been able to be put out. And I don't understand why they don't just put a series of pipes down into it to get that energy out of there and create electricity from it. I'm curious as to where you would want to put a geothermal power station that only has a temporary use. Can you tell us where that would be?
No, I actually thought or read that geothermal energy does not stay at that specific location forever. You know, it actually dries up.
Well, I don't know where that information comes from, but when you get down deep enough into the earth to really use geothermal, it radiates from the core 360 degrees in all directions. I mean, it's not where it's, unless you're tapping into maybe something near a magma vein of a volcano, and that gets cut off or diverted so that the heat coming from that isn't continuous. But I've never heard of a geothermal setup that uses a live magma vein for its heat source. That's why this new technology this company has, which, let me just explain for a moment. This company has been doing all sorts of drilling, fracking and other deep well drilling for years. And I think it just, a light bulb went on top of somebody's head one day and said, you know, we know how to drill deep into the earth, and we get down there and our sensors tell us it's enormously hot from the geothermal that's coming up from the earth's core, which is an ongoing furnace down there. And somebody said, well, you know, why don't we pour water down there and get steam back and start generating electricity? And that's basically what this enhanced geothermal system is. It's very simple, yet very sophisticated, based upon their ability to drill ultra deep wells that they can stabilize. They're not going to collapse. They're not meant to bring up oil or gas. They're specifically meant to reach a level deep enough to have the heat high enough to turn water pumped down there into very high pressure steam. And that steam will stay intact all the way to the surface and give a tremendous amount of energy output. So again, I've never heard of a geothermal source, especially if it's a geyser or a thermal vent drying up. But they do, well, let me say this. There have been geysers, which are water shooting out of the ground from a heat source at Yellowstone Park, that have changed over a course of 40 or 50 years. They're not as regular as they used to be, and some of them have stopped actually pumping up geysers. So that may be an instance of a geothermal vent moving or changing underground so that the heat doesn't come up in that exact spot. But that is not something that would happen with this particular technology I was talking about. I hope that answers your question.
Yeah, it does. Thanks.
Thank you, Mr. Saif, for your questions. Now we'll move to Dr. Magaidi.
سامعني يا أستاذ؟
نعم صوتك واضح.
شكرا حبيبنا الغالي، شكرا.
الله يحييك.
في البداية حبيت نتدخل مع المجموعة لكن للأسف إن شاء الله هتواصل مع الدكتور سيف العابد أو الأخ الأمين العام، لكن ستأتي فرصة أخرى إن شاء الله وأتدخل معهم. Thank you. أشكرك جزيل الشكر أخونا سالم على هذه الملتقى القيم. For Dr. Robert, thank you very much. And I have a general question about your experience. In which fields of renewable energy we have the most important patents and on the world, on USA, or why in this fields and not in another fields? And what do you think about combined systems of renewable energy according to their efficiency?
Well, to answer your first question, there are so many patents out there that have been issued on various renewable energy technologies. I probably don't know enough about all of them to give you an accurate answer. I don't want to speculate. In my opinion, some of the newest wind energy patents are fascinating. As well as a couple of the tidal energy patents that I've read. I'm involved in a couple of projects right now to keep me very busy all the time, and I don't really have the bandwidth to absorb as much new technology, especially reading the patents, as I used to and would like to. So I don't feel like I can give you an answer that would totally satisfy you. In my opinion, though, the wind and the tidal forces, and possibly even the wave forces, have some of the most interesting patents, and people are focusing more on them than things like geothermal. You have to have a very specialized technology to get at the geothermal. So that limits it to just a couple of companies in the deep well drilling field to achieve what I was talking about in the presentation. But
because this is, excuse me, this is for the reason because this two kinds of renewable energy not be related to another problem like environmental problem or water problem or like something like this, like something.
I'm not sure I understood that question. I'm sorry.
Because this is the wind and coal sources of renewable energy is not related to another fields like environmental or water or like something like this.
Well, biomass is related to a field that is the waste energy field or the waste problem. That's directly related.
Wait, but biomass it's not related at the waste, but it will be at the food either. It's a problem of the food and bioethanol and bio energy either.
Yes, but it looks to solve those waste problems, whereas most of the other renewable energy is not looking to solve an environmental problem as much as it is to take advantage of some environmental circumstance like the natural waves or the natural tides or the natural winds. And I think those are the most profitable and where most of the patents happen, because people look at it as a free resource. If there's a free energy resource out there, that's the best beginning for a venture to try to exploit.
Thank you very much.
You're welcome, sir.
Thank you, Dr. Magaidi. Now we'll move to Marwa Mansour.
Yes, Engineer Salem, I hear you. You
Yes.
hear me?
Yes, we hear you.
Yes.
Okay. Thank you for this fruitful webinar. And my question is about the sea twirl. You mentioned in your presentation that the sea twirl is offshore. Can we have a sea twirl in onshore, and what will be the difference between both of them? This is the first question. The second one is what is the lowest cost of source of type energy that you mentioned in your renewable energy? What is the source with the lower cost? And thank you.
Okay, we'll have to ask that second question again because I'm not sure what you mean, but the Stirwell technology could be put on land, but its main purpose, well, two main things about it. Number one, it floats. And because it floats, it can be placed places where land-based or other sea-based systems that have to be anchored can't be placed. And that's a major, major advantage. But if you took it and put it on land, you'd have some of the same problems as horizontal axle wind generators. And that is, it happens with all of these huge fields of the propeller type that you see. They create vibrations that go into the ground. They're spinning, and whether it's a vertical or a horizontal axis system, they create vibrations. When those vibrations go into the ocean, they disappear. There's nothing that's affected by them. But when you have something that can spin and generate as much power as the sea twirl, it probably, number one, it probably wouldn't work as well on land because the winds are not anywhere as strong as they are out on the open ocean. And that's what that's designed for. Although it is designed to take hurricanes and typhoons. So if you placed it in an area that you had it on shore, and even if it was in high, what do you call it? High wind conditions, it would still be good, but you'd again have the vibration and the torque that is placed on the base into the ground becoming a problem eventually. And that's why it's a sea-based system. Now, can you repeat your other question?
The other question is about the cost. The cost of each type of renewable energy that you mentioned. What is the type of with the lower cost? Can you make
the cost of each? That is so variable. Again, I hate to speculate. There are wind systems that are very inexpensive, depending upon how large you make them. As everything scales up, of course, the costs go up. And
I think hydroelectric is a lower cost.
It depends on what type of hydroelectric. And also, I really pushed the pumped hydro because I think the pumped hydro is a great system. But one of the things I didn't mention is that in a closed loop pump hydro, you only get about 5 to 10% of the energy out of it in reality, because the cost of the energy, even if it's low cost, to pump the water up, negates part of what you get, the water coming down. And any system, you really have to look at it and say, okay, what are my initial costs? What are my construction costs? what are the costs long term, not just for the land or the rights in the water or the maintenance or the renewables inside of the technology, things that have to be replaced, things that have to be managed. Even the best systems have a management cost that sometimes takes 10 to 20% of the profits out of the system. So saying which one is the best cost, I have to say, how much power do you want to make? How much land or water space do you have the rights to place that system? How much investment capital do you have to start the system up? And how soon are your investors expecting ROI or a payback in full on their investment? All of these are important considerations in saying what is the cost, because costs are relative. They're relative to expenses, to expectations, to the lifespan. I mean, you could have something that's very inexpensive, generates a lot of power, makes you a lot of money, but it lasts for a day.
Now,
So what do
according
you
to the
get out of
capex
it?
and the opex, the capex and the opex for the same megawatt output.
Yes, I think what Mr. Robert means, he means what we call it the levelized cost of energy, which is related to the capex and the opex for the certain duration of time. So usually now the cost of levelized cost of energy of solar PV and the wind is almost the cheapest cost from the other types of renewable energy sources. It's
Can I
yeah.
say something that Perscovites that I was talking about early on, that new technology that is ultra thin that you're going to be able to paint on or place paper thin sheets of it. When that gets up to 30% or better in how much power can be absorbed from sunlight, then we're talking about probably the best technology that could be invested in or purchased and used, because it's going to give you an increase in the power and a decrease in the cost, especially as it gets more widely used. The cost will go down greatly, and it's something that is really cutting edge at this point. So no one really knows how far the technology is going to go. I'm sorry to have interrupted you.
No, it's the same thing. Yeah, it's the same answer that I have in my mind. So I would like to thank Ms. Marwa for her questions.
Thank you very much.
Thank you, and we'll move to. I don't know how much time Mr. Robert can stay with us, because we have.
I have some time. I want to answer at least a majority of the questions. I don't want to leave people hanging with questions that didn't get answered. So if I can answer the questions, I will.
Yeah, thank you. We appreciate that. We'll go to Ilham Muhammad.
شكرا مهندس سالم على هذا الملتقى العلمي. سؤالي لمستر ريبر. Do you think that green hydrogen production is really effective trend for future energy production?
It has its good points. I've never been a big hydrogen fan. It has too many downsides as far as I'm concerned. Not only in production, not only in storage, but its volatility as a resource. That alone scares me. Hydrogen is we've all seen the Hindenburg go up from a spark. I don't know if you've ever seen a close-up hydrogen explosion, but they're very dynamic, to say the least. I'm a big fan of naturally occurring energy sources like geothermal, wind, wave, that can be exploited because they're there all the time. You don't have to build a huge facility to either produce, contain, and protect yourself from anything that might happen with that resource. The wind, the water, and geothermal are never going to hurt you, whereas hydrogen always has that potential. So any sort of hydrogen is something I'm not sure I'm a big fan of.
Thank you, Mr. Ilham, for your questions. And now we'll move to Ali Imran.
Hello.
Yes.
Hello, Ali. How are you?
First of all, I would like to give a full thanks for all engineers for this valuable information here in this webinar. My question is about, right now I am in the final year of my university. I'm studying renewable energy engineering. Our graduation project is about designing and implementation 10 kilowatt horizontal axis wind turbine, but due to the high cost, we cannot do practical and technical implementation in the real life. So we are more opportunities like internships that fully funded at the next month to do this practical skills. So can you give a recommendation or help us to do this?
I think, Engineer Salim, I think that's a question you could answer more easily with your connections.
Yeah, usually there is some other, there is money now, there are many companies, they have, they exist in Arabian countries. I think if you contact them and show them your vision, show them your, what do you call it, a summary of your ideas and the projects, they can help you to get it done through them or through some other areas. It depends on the country that you are in. In Kuwait, there is some other authorities. They can receive the proposals of any project, and then they study it, and then they give approval for some of them. I think in Saudi Arabia now there is a huge developing companies. I think it depends on the areas and depends on the company. You can just try to contact them, show them your willing, your motivations, and I think they will help you. Yeah. And we hope that you can get it soon, inshallah.
We hope you succeed.
But the question is how to get a summer training or some of month training in these companies.
I don't know, where are you from, Mr. Ali?
I'm from Palestine, Hebron.
Palestine. Palestine, I think in Jordan, there is like a German academy, they call it RENAC. RENAC, it's very active in giving training. I think they cover some course. Also, you can reach the RICRI, the RCREE or EE. RICRI, it's Arabic authority. They I think provide some training for the engineers and overseas, sometimes in your country. You try to reach RICRI and the RENAC, and I think, yeah, when I just try to reach me in the number WhatsApp showing in the webinar advertisement post. You will find the number there, and you can share some information about it.
Okay, thanks.
Thank you. Now we'll move to we finish Ali. Ahmed Saif, if he is there.
Good evening, Mr.
Good evening. Hi, Mr. Ahmed.
Good evening.
Hi, in Salem and hi in Robert. I have a question for energy sector. The problem of renewable energy now, it's storage the energy. I want to ask what the suitable way to store the energy for the future, flow battery or battery like general, and the way to transition the energy. I heard or I read a report that the way to transition the energy without cable, because the cables make resistance for energy, but not like long distance. I want to know what the future have for these two questions.
Well, we already did a whole seminar on storage.
Yes.
we should run that again. I'm not the biggest fan of batteries per se for storage. I believe that kinetic energy storage systems are probably the best for long-term storage. Any chemical solution over time is going to degrade. Even the famous Tesla batteries over time have shown that they can't hold the charge that they originally held. Whereas if you hold the energy as a kinetic energy based system, the energy never goes away. The energy is always there. And there are probably a half a dozen good kinetic energy based energy storage systems now coming on the market that are capable of holding enormous amounts of power in a small space. If you contact me directly or through engineer Salem, I can send you different companies that are currently doing some great energy solutions for long-term storage. And some of them, I mean, if you're talking, you have to have energy storage in a very compact space, and it's not in a really crazy amount of energy, then for a short term or even for a medium term, you might want to go with a chemical battery based system, whether it's a flow battery or otherwise. But if you're looking for a system that really has potential for communities or cities in general, then there are some other systems that some of them take a little bit more space, some of them take a little bit more engineering to get them going, but they provide you with a kinetic energy based storage system that has very few downsides to it that the batteries all have. I mean, if you just look at the battery as itself, some of them look very nice, but the production of the battery, most of them have severe ecological downsides to their production. And if you don't factor that into the costs, both environmentally and financially, then you're not really knowing what the battery's value is or what its long-term cost is. Does that answer your question?
Yeah. Thank you. And I will contact you for more information in storage. So, thank you for your time. شكرا لك مهندس سالم.
Thank you, Mr. Ahmed. Now we have last two questions. We'll go back to Hannah if she is still there. I hope she can use the mic now. Hannah Abdul Malik. She raised the hands again. Maybe you can use the space to remove the mute. Let's try this.
Can you unmute her? Or she has
Yeah,
to do it.
I'm trying, to ask her to unmute. Okay, we'll go to Mr. Dr. Mgaidi. I think he has another questions or comments. تفضل دكتور مقايدي.
Now, just to thank you for this, all this information, useful, very, very, very useful information for students and for all our young researchers. And thank you for all this, Mr. Robert and Mr. Salem. Thank you very much.
Thank you.
My pleasure.
It's our pleasure.
Thank you.
Now we'll go to Mr. Abdul Majid.
Yes, Assalamu alaikum. Can you hear me?
Yes.
Yes.
Yes. Excuse me, Engineer Robert. I would like to ask about your opinion for the future for the CSP. Unfortunately, we heard in the news that the last year, one of the largest plant in the world, which is in the United States, in Biomass, it has been shut down for some reliability reasons, where many people building on the CSP because they are they can dispatchable electricity to the grid, unlike the PV. So how do you see the future of the CSP? Do you think it will have some more growth after resolving some of its reliability issue, or you think the PV will take over and will not see it in the future, more CSP plant?
Okay. Can you? The abbreviation CSB means
it's thermal concentrated solar power. It's
okay. I know what you're talking about. Are we talking about the concentrated heat into the salt base?
Yes.
Generate the power. Yeah.
Yes.
I have mixed feelings about it. I think in the areas where it's used, like in the Arizona desert, it's an excellent technology, but it's very, very limited in what it can do. The ability to place it other places, well, you can probably place it in the Nevada deserts. There's probably enough open land if they wanted to dedicate it to that technology that they could make it useful. But it has the same limitations as any solar-based technology, which is you have to have the right sunshine, and once you've got it and it's concentrated, can you turn that heat energy into the proper power output that will be useful? From what I've seen, it generates a hell of a lot of power for the amount of sunshine it's using. I haven't really had a chance to look at the numbers when it comes to what it costs to build or what it costs to run, but I see a couple of downsides in its operational capacity, in as much as if it's not focused perfectly, you don't get the right amount of energy. If every one of those mirrors isn't outputting correctly, you don't get the right amount of energy. But even when you're getting the right amount of energy, if there's some sort of glitch in the system, which this is right out of a James Bond movie type glitch, if the focus isn't exactly where it's supposed to be, you end up burning down the facility. Because in essence, what you've got is a thermal laser that is concentrated on one spot to absorb that energy. But if for some reason the mirrors slip, the mirrors are misaligned, something's wrong with the computer algorithms that are keeping the mirrors moving and focused, well, then all of a sudden you've got a $1 billion facility that burns itself to the ground.
Yes.
Or worse, it refocuses and hits a passing plane and takes it down. I just think it's not something you're going to see sitting outside of every city. And anytime you have something that has to be put out in the desert, as we know with nuclear plants, which a lot of them are in cities nowadays, you still have to, or even a coal plant, you don't want it someplace around people. You have to have huge transmission lines, you have to have huge transformer systems. You have to be able to transmit that energy a great distance to make it useful. And again, you're only getting how many hours out of the day that you're powering something. Although the heat may stay in the salt overnight to a certain extent, that can still drive energy production. It's not the same as a wave farm or a wind farm. That, well, even wind farms, the wind doesn't blow all the time. I'm getting to be more and more of a fan of ocean energy because it doesn't seem to dissipate. It doesn't seem to go away. That and geothermal are more of a safe bet economically and even politically for most countries than anything that's creating the type of heat and has to be managed the way one of these mirror facilities has to be managed. I'm kind of torn. I like the technology. Believe me, it's unique. It's powerful. It's something that, especially, it's visually dynamic. I've seen such great pictures of it. It's something that you go, wow, now that's the essence of a power facility. But it has some downsides that I don't think it's a long-term solution.
Yes, it's as you said, Mr. Robert. It has operation and maintenance costs very high. If we compare it with other renewable energy sources, the CSB, it has a higher cost of operation and maintenance, but it is more reliable than solar PV and wind. Since it has like the molten salt, which will make it energy storage for the CSB. And as you said, Mr. Abdul Majid, they use it as the priority of dispatching in the grid, which gives more stability. But the downsides, as Mr. Robert said, it has many operation and cost considerations. It's in GCC, they are using almost CSP in most of the projects. They need it as part of any renewable energy project because of dispatching consideration. Is it wider use? No, it's going to be, I think, in my opinion, it's going to be less than solar PV. Thank you for question, Mr. Abdul Majid.
Thank you very much.
Thank you.
Thank you.
Now we'll go for the last questions with Lakihal. I hope I can see him. I'm not sure about the name.
السلام عليكم. تسمعني الأستاذ العجمي؟
Yes, ممكن can you introduce your name because we can't.
سهام لكحل from Algeria. جزائرية.
يا حياك الله.
الله يحييك. شكرا على الويبناير هذا وشكرا على المعلومات القيمة وشكرا على الأساتذة الأفاضل وشكرا على الاستضافات هذه. شكرا جزيلا على المعلومات القيمة اللي تحصلنا عليها. Good evening or good afternoon, Mr. Roberts. Question for you.
Yes.
The question is regarding the photovoltaic kind of energy. So you have mentioned in your presentation the perovskite, like an alternative of silicon. What are the limits of this technology, especially the use of nanotechnology is in this kind of energy? One, and what is the future of this kind of material, especially it's a new one, and well, we have a lot of to do or to prepare or to produce in this regard or in this field of energy. Thank you.
Well, it is a new technology. It still has a lot of the development phase left. So to forecast whether or not it's going to be what it thinks it's going to be is just that, a forecast. But from everything that I've read and seen, it has some amazing attributes that place it well ahead of silicon-based PV systems. It also, even at this early stage, produces 33% or a third more power than standard silicon-based PV. The fact that it's ultra thin compared to the structure that most PV has to be in to withstand just normal elemental problems, rain, hail, wind, etc. The fact that it might be able to be painted on at some point, if not just a thin film that you could put on the tops of buses, on the sides of buildings. They're even saying that they can integrate it into glass for windows. So you could have a building that's completely glass, like many skyscrapers are, and have it completely PV. That, to me, says that it has a big future. Whether or not that comes to fruition has a lot to do, I think, not just with the technology, but geopolitics. Since a lot of, probably 90% of the solar panels come from China right now, the Chinese are either going to try to get that technology for themselves and start selling it, or they're going to try to block it in the marketplace somehow. I'm not familiar with what the patents are on perovskites, but everything I've heard about it, it seems to be well protected, which tells me that it will make it commercially within the next couple of years. I think it's how they manage the market, who their strategic partners are, how they integrate it into the marketplace that already exists without trying to make silicon PV out to be the bad guy. It's just the old technology. Everybody wants the new stuff. There's nothing bad about PV right now, except it's too expensive, it's fragile. Most of it comes from China. And those are downsides that, you know, either people are going to live with, or they're going to turn to a new technology. And, you know, there are always first adopters. And that's what's going to happen in the industry. You're going to have a certain level of the industry and people and corporations adopting the technology. And then once enough people say, oh yeah, this stuff is great, I love how it works, I love how it's integrated into my factory or our production lines or my home, then you're going to see it explode. So yeah, I think the market is there for it. I think the technology is sound enough. The fact that you can make the perovskites from any number of different chemical compounds, as opposed to you have to have silicon, that makes it a game changer. That makes it something where, as long as they have the proper patents, these initial companies should fare well. But even if they don't, and a lot of companies start being able to develop it, maybe that's for the best, because you'll get competition, you get lower prices, you'll get more innovation in its development, and then we'll start seeing solar not need CSB facilities. We'll start generating power just by having these thin, wafer thin elements all over modern cities that are generating enough power to run the city. So yeah, I see a big future for it. It's something that I think anybody with good investment capital at this point should be looking at as possibly to get in on the ground floor of it. Did that answer your question?
Yes, I think, yeah.
I hope so.
Yes, and I think we reached the end of this webinar for today. I think we took almost more than half an hour extra for Mr. Robert. Thank you, Mr. Robert.
No problem, my friend. For you, anytime.
Allah, thank you. We appreciate your participations and your interest to be part of this webinar. We always welcome you, Mr. Robert, as a great friend, a great inventor, a great expert in the field of energy sector in general. Thank you, Mr. Robert. We hope we will see you again in future here in Kuwait or in the other events soon. Thank you.
I hope so.
I hope so, inshallah. And we'll see you again, inshallah. And again, we thank our speakers for the first sessions, Mr. Muhammad Ta'ani, and also the Dr. Hadi Al-Madkhali, also Mr. Dr. Mustafa Tomi, Dr. Muhammad Ghaith, and Dr. Saifuddin Al-Abid. Also, my thanks is to our audience who came attending this webinar. We hope they enjoyed the different subjects that have been raised here during 3 hours. Regarding the material from our side, the Sustainable Solutions Company, we will prepare a report including a summary of this event and also including the presentations that are delivered by speakers. Will be prepared as a PDF file. Then we will send it to the people who are interested to have one. Just try to reach us with the WhatsApp number that you got it for registrations, which is 965 is the country code of Kuwait, 677-27789. And thank you, and we'll see you again in the near future. We'll say goodbye.
Great. Take care. Bye-bye.
Yeah, bye-bye.
الله يعطيكم العافية جميعا.
الله يعافيك دكتور محمد، تشرفنا والله. نشوفكم على خير إن شاء الله دكتور مصطفى، دكتور هادي، والبقية بالحضور. مع السلامة.